Hey everyone, so our project is called NAS, a peer to peer decentralized sharded file system. So, the motivation why do we even need a sharded distributed storage system? Let's take the office for example. Michael, we have, who's the regional manager of the office, who doesn't do a lot of work in the office, so basically only has 2% of his storage. Then we have Dwight, who's a salesperson who makes costs and does a lot more work than Michael, so basically uses about 22% of the storage. Then we have Pam, who's a receptionist and office manager, so she keeps track of a lot more stuff and has about 30% of storage used. Finally, we have Oscar, who's an accountant to the office, who basically has 96% of his storage used because he keeps logs of almost everything that happens. So, currently, this network looks like this. Michael uses very little storage, where Oscar uses almost all his storage. He's running out of space and now he needs storage. The office does not have enough budget to buy external storage. So, how will they still store all their data? They would use NAS, a peer to peer decentralized file system that focuses on efficient space usage. All the files stored in the system will be sharded, and each person will be able to access their own file whenever they want. All communication will be encrypted, and all the nodes in the network will have their storage grow symmetrically. So, after the network is installed in the office, we'll be able to see that the storage is split across all the network, and now everybody can use more storage if they please.
Now we're going to talk about the techniques used in our implementation of the network in depth. So first we're going to talk about sharding. Basically what we're doing is we are breaking our files into chunks and spreading them across the network. As you can see, a file is spread across all the nodes in the network, and a 1 TB file is spread equally across all the nodes in the network. So we use ledgers. So the ledgers are basically a representation of the current state of the entire network. Each node stores a copy of the ledger which is synchronized, and ledgers store the IP and the public key of every other node as well as all the files stored across the network. All the communication between nodes is encrypted, and this is crucial. We use the RSA Python library to generate private and public keys for each node in the network. A message that is sent across the network is encrypted using a public key before sending it across the network, and it's decrypted using a private key by the node which is not shared with anyone else. By using encryption, we are preventing access to unauthorized users in our network. Communication. So in our network, there's no concept of a master-slave. Each node acts independently. A node can send out requests for a file to be read or written to the network. Each node runs a server that supports multi-threaded sockets for multiple requests at a time. As you can see from the example, the node A performs a read request and broadcasts the read request across all the other nodes present in the network, and the other nodes sends shards of that file back to the node A. Hence, the node A will have its complete file.
Alright, so now let's talk about another technique we use, which is known as locking. So each node has the capability to lock other nodes in the network. So how we essentially use this is it helps us prevent writing consistencies throughout the network. So here's an example of A trying to perform a write. So what it does is it sends out a lock request to every single other node, and it locks it from performing any other additional write. But it's important to note that each of these nodes are still available for reading files. So this is another feature that we plan to implement, but we haven't done so yet, and it's load balancing. So this is a method that is used to redistribute sharded files across the network, which is important for our symmetric growth requirements. So we would basically need this technique whenever the number of nodes in the network changes. So for example, like adding a new node into the network or removing a node from the network. So we make a couple of assumptions in our project in order to achieve our specifications. So the first one is that every node is always active and does not shut down. The nodes are also not malicious and they don't wish to harm anything in the network. And finally, the maximum file size is smaller than the space available by the node with the smallest storage. All right, now that we have that out of the way, let's go towards the demo. So we start off our demo by running the NAS program, which opens up the GUI interface that we built for this program. So we have two basic options. One is to join an existing network, and one is to create a brand new network. So for the purposes of this demo, we're gonna join an existing network that we've already created. So we start by entering in one of the hosts in this network and enter in their public key as well. So now we hit join. So we're greeted with a blank window because we basically don't have any files stored on the network right now. So the current network consists of two nodes, which one of them being us and the other one is the computer we just connected to. So now let me try adding a file to this network. So I'm going to start by adding in this simple Python script. And you can see that the sharded column turns true because this file is now split into two parts and encrypted and sent to the other nodes in the network. So right now, if I try to pull this file, it doubles the file size because it just downloaded the entire file, and I can now open this file. There you go. And the sharded column turns false because it's now hosted on our local directory. So I can even add slightly larger files like PDFs, and it works the exact same way. You can see the sharded column is true again. I can download the file. And I have the entire PDF. So now it's important to remember that all of the information that we're storing is completely encrypted so that other nodes on the server cannot open up our files. And lastly, we can also save images. So I can pull it and open. And you can see that images work as well. It essentially works with almost every type of file. Thank you for watching our presentation.